So, hi, my name is Eddie Weitzberg. I'm a physician and a scientist. I'm a professor in anesthesiology and intensive care. And my research since my start as a PhD student until now has been on nitric oxide. And for many years I was focused on exhaled nitric oxide as a monitoring measure of airway inflammation, mostly in asthma, of course. So the field of exhaled nitric oxide actually started in Stockholm in Sweden by two independent groups. One group was Lars Gustafsson's group, who was the first to show that you could find nitric oxide in exhaled air in both animals and humans. And our group, which was then led by Jan Lundberg and Kjell Alving, we were interested in airway inflammation, and when we saw his article we started to measure exhaled NO, and we found that it was increased in subjects with asthma, which we published in 1993, 2 years after Lars' publication. And both these research groups filed patents, which we kind of merged in a company called Aerocrine, which was started in 1997. And me and Jon Lundberg, another collaborator, not Jan Lundberg, but Jon Lundberg, actually took leave of absence from Karolinska Institutet and started the company after getting investors to fund the company. Our task was mostly to find good people that could run the company in the long term, and that was pretty easy in Sweden at that time because the pharmaceutical company Pharmacia had joined Upjohn at that time, and there were many people who left Pharmacia, and we could find very good people in marketing, in technical development and so on. So the first thing to do was actually to get some device that we could measure exhaled NO that we could get out to the clinic. And the first system was called the Aerocrine system. It was based on chemiluminescence, which is a very fine technique but very expensive and very complicated machine. But we actually bought machine from Ecophysics, and we set up a kind of a system with flow control, which is extremely important, with feedback from a computer and so on. And this machine was extremely big, you know, it was like 1.5 meters high and 70 centimeters wide, very heavy, had to be rolled on wheels and so on. So it was not an optimal product, but it was still important for us to have something to offer if people were interested in measuring exhaled NO in the proper way. So this was in 1998, 99, so on. So then the company started to try to make their own chemiluminescence-based technique to measure this, and they came finally up with the NIOX, which is also a chemiluminescence-based technique. It was much smaller, it was like a computer with a screen, and you could exhale into the computer. It was very well controlled. Very nice machine, and it was started to be sold in Europe in 2000 and was approved in the FDA by the FDA in 2003. And then we had the NIOX Flex, which was the same machine or device, but you could exhale at different flow rates, and that means that you could calculate the so-called flow-independent parameters. You could kind of pinpoint where from the lungs the nitric oxide came when you exhaled. While NIOX and NIOX Flex were sold to customers, the company had a very big focus on trying to get a smaller device based on a completely different technique, namely electrochemical detection. And after a lot of work, the company had a product which was much, much smaller. It was like a coffee pot. It was high, 30 centimeters high, and you can hold it in your hand and so on. So it was a handheld sensor, and it took some effort to get the electrochemical detection to work with these small concentrations of nitric oxide that you have in the exhale there. So this was the NIOX Vero, and I think it was launched in Europe in 2005 and launched and approved in the US in 2008. And then the company could start to sell these NIOX Vero devices to doctors' offices and so on, private practitioners and so on. So it was a big step, you know, compared to the NIOX and NIOX Flex. And then the company developed the NIOX Vero into something called NIOX Vero, which is an improvement of the NIOX Vero. Still a small machine that you could, or device that you could use on a table, on a doctor's table. And this was launched in the US in 2014. And this is still the device that people buy and use. And there is a NIOX Vero nasal now that you could use for if you want to measure nasal levels, which is adequate if you want to screen or help setting the diagnosis of primary ciliary dyskinesia. And that was, I think, introduced in 2017. So there has been a stepwise development from a huge machine to something very small that you could have. You could even have it at home, but I don't think it's used very much at home, but it's a very small device. So it's been a very intriguing journey for us scientists, of course, because we are not extremely good. We are biologists, and it was impressive to see all these technical improvements that has come over the years to try to make this reliable and a machine that you could have in the doctor's office or so on. So it's been very exciting. And I think there's a great future for FeNO. I mean, if you see the latest recommendations from different organizations like the American Thoracic Society or the UK NICE or the National Heart and Lung and Blood Institute, they all point towards the use of FeNO to guide asthma treatment. So I think there is a great future for this. Okay, this was kind of a short version of the technical development of the devices that we have had over the years. Thank you.